This is section 3.3, problem number 3. Plug my mic in. This problem, it gives us this function here, negative 2x cubed plus 39x squared minus 240x plus 4. Tells us that this function has one maximum and one minimum, and it asks us to find them along with their values. So we're going to go through the same process that we went through in the examples from the lecture to find out when this function's increasing and decreasing. And then based on that, we'll use the first derivative test to determine where we have a max and a min. So that said, first step, to determine when a function's increasing, decreasing, we find the critical numbers. And to find the critical numbers, we have to find the derivative. So we'll find the derivative using the lovely power rule. So we have negative 6x squared plus 2 times 39, that's 78, right? Is that right? That's right. X. And then minus 240. And oh, 6 goes into all of those evenly, doesn't it? Because to find the critical numbers, we have to find out when this function is equal to 0. And we have to find out when this function does not exist, but it exists everywhere because it's a polynomial. So we really don't have to worry about this part. And so we'll just have to find out when the function's derivative is equal to 0. And I was just noticing that 6 will go evenly into all of these numbers here. So it looks like I can factor a 6 out, right? If I set this equal to 0, I can I'll factor out a negative 6. And I'm left with x squared minus, what is that? 13. Is that right? 6 times 13 is 78. That's right. That's right. Yeah, that's right. 6 times 13 is 78. And then 6 goes into 240 40 times, because 6 times 4 is 24. So I have this equals 0. And then it looks like I can factor this, right? Like I have to find two numbers that I can multiply and get negative 40, add and get negative 13. What numbers? Let's see. I'm just going to go down the list because I can't think of the numbers right now. 1 times 40, 2 times 20, 3 won't go into 40 evenly, 4 times 10, 5 times 8. That's the number. When I can't think of the numbers, I just go down the list and the numbers come up. And if they don't come up, that means it can't be factored, right? If I get like all the way down to all the factors, that means I can't factor. So, but I got 5 times 8. And wait, I thought I was good. Oh, I am good. You know what? I made a mistake right here. When I factored out a negative 6, this ends up being a positive 40. I put negative 40, but it's positive 40 because I had a negative right here. And a negative times a positive will give me a negative, not a negative times a negative. Negative times negative would give me a positive there. So that's a positive 40. So that means that I have negative 5 and negative 8 here. Those work, right? Negative 5 times negative 8 is positive 40, and negative 5 plus negative 8 is negative 13. If you're not able to factor, you can go ahead and use the quadratic formula, which I did for the problem, that the second example that I worked in the lecture for this section. I had to use the quadratic formula because those numbers were a mess, let me tell you. So So in this case, I get these nice numbers. I'm very, very happy because that means that either the x minus 5 has to be 0, or the x minus 8 has to be 0. The idea is that I'm multiplying three numbers, -6, x minus 5, and x minus 8. And when I multiply them, I get 0. So one of them has to be 0. One of them is a -6. That's not 0, and I can't make it 0. It's a constant, as in it's constantly -6. It's never anything other than -6. So the only other possibilities would be the x minus 5 and the x minus 8. And then solving for x here, I get x equals 5 and x equals 8. And these are my critical numbers. So this is the first step for finding out when your function's increasing, decreasing. And we do this twice in the, we do 2 examples of going through this process in the lecture video. Well, I do this twice, I should say. Once we've done that, then what I like to do is I like to make a number line, and then I put my critical numbers on the number line in the order that they would appear on the number line. And what that does is that breaks your number line up into intervals so that you can then pick test numbers in each interval. So pick a test number. Notice there are 1, 2, 3 intervals. So I'm going to pick a test number in each interval. That's just a number, any number that you want in each interval. So I'm going to pick 0 and as my test number that's less than 5. A test number between 5 and 8. I'll just do 6. And then a test number bigger than 8, let's do 10. And then, so my test numbers are 0, 6, and 10. Once you have your test numbers, then you plug those into the derivative, which again was, I'm gonna write that out because I don't remember what it was. You know what? Here's something. Here's a little trick. When you write out your derivative, if you have factored your derivative, write it out in the factored form. That'll make it easier to tell if your function's if your derivative's positive or negative right there. So here's what I mean. This right here, this is our derivative, right? But I'm not going to write my derivative in this form right here. I'm going to write it in this form down here, the factored form. Because I'm trying to figure out where my derivative is positive and where it's negative. Or I mean, whether my derivative is positive or negative at my test numbers, and like just using the factored form, that'll make it easier to tell. So I'm using the factored form, and I will plug in my test numbers now. If you don't want to use the factored form, that's fine. You can use the original form of the derivative that we got, but I like the factored form. It just makes it easier. I don't have to do as much calculating. Because like, look at this. When I plug in, I guess for the 0, maybe the 0 would be really easy in the regular form, but the others are easier in factored form. So, but here, let's look at the 0. So I have -6 times 0 minus 5 times 0 minus 8. Again, I don't care. I do not care what this value is. All I care about is if this is positive or negative. And I'm like, I know that -6, I know that's negative, right? 0 minus 5, I know that's negative. And then 0 minus 8, I know that's negative. And so then I say negative times negative is positive times negative is negative, which tells me my function is decreasing right here. When the derivative is negative, the function's decreasing. I'm going to draw a curve, like a decreasing curve to the left of 5. That's where my test number came from being to the left of 5. Now I'm going to do the same thing for f prime of 6. So I'll have -6 times 6 minus 5 times 6 minus 8. Again, I do not care. I don't care. I don't care what the value is. I know that -6 is negative. I know that 6 minus 5 is positive, and 6 minus 8 is negative. Negative times positive times negative ends up giving me a positive, because negative times positive is negative, and negative times negative is positive. So that tells me my function's increasing right here. So I'm going to go ahead, go up to my number line and draw increasing to the right of 5. And look at, right away I see that I have a min at 5, just like that. Now I'll plug in my 10. I have -6 times 10 minus 5 times 10 minus 8. And again, I don't care what the values are. I know -6 is negative. I know 10 minus 5 is positive. I know 10 minus 8 is positive. So I have a negative times a positive, which is negative, and then times another positive, which is still negative. So my function's decreasing here, which means, so again, if the derivative's negative, that means the function's decreasing. So I go from increasing to decreasing, which means I have a max at 8. Look at that. A min at 5, a max at 8. I'm gonna go here. So a min at x equals 5, a max at x equals 8. And then for the values, let me just check my answers. So far, so good. And then for the values, what you need to do, or what they're asking you to do for the values, is to plug in the number. So like plug in 5 for x. And make sure you use the original function. So just use f of x, don't use the derivative or anything. They want to know what the y value is. They want to know, how low did it go? That's what they want to know. So, and then for the 8, for the value, they want you to know, they want you to plug in 8 for x into the original function. They want to know what's the y value? Like how high did this maximum go? Like what was it? So I am going to, here's what I'm going to do. I'm going to use the calculator. So plugging in 5, I will get -2 times 5 cubed. I'll write the cube in a moment, plus 39 times 5 squared, which I'll write in a moment, minus 240 times 5 plus 4. So again, I'm using the original function, using this right here. And let's see. So I'm just adding my exponents. 39, that's a square. Okay, so now I'm going to go to the calculator. Oh, I love you, calculator. Because you're going to make everything nice. Well, less work. You're going to give me less work. I think I did all that correctly, but let's see. -471. Yay. Okay, so now I'm going to plug in 8 for x. So I'm just going to go to the calculator and replace all my 5s with 8s. I get -444. Yay, wow. There's not a huge difference between the local max and the local min, but that's how it is. That's how it is. I hope that helps. Take care. If you have any other questions, send me a message on Canvas or an email or come to one of our work sessions. Bye.